Assalamu alaikum. Good afternoon, everyone. First, doubts related to this exercise. This is our last week homework. Matter and gas law, exercise 2. If you have any doubt, just mention the question in which you have doubts. I will discuss that. Mention the doubt, the question in which you have doubt from this exercise. Question 10. So question number 10, describe the movement of the molecule. Describe the movement of the molecule in solid. So what is the movement of the molecule in solid? As we know, the particles are tightly packed together and they only vibrate. So molecules are tightly packed together, vibrate about a fixed position. And how we explain the movement of the molecule in gases. They're vibrating and moving randomly. Vibration is there for all and moving randomly. Next question, a closed box contain a gas molecule. In terms of momentum, how the molecule exert pressure on the wall. So basically what happened, like you have a container which is filled with a gas. So these gas molecules are moving randomly. The gas molecules are continuously changing the direction. So when the gas molecule changes the direction, there is a change in momentum. And due to the change in momentum, they exert force on a specific area or unit area. The force on a specific area or force on unit area, it will create a pressure. So how you will write this answer when gas molecules are moving randomly? They hit the wall and bounce back, which change the momentum, because momentum is a vector quantity. So if the direction change, the momentum will change. Due to this change in momentum, molecules exert force on unit area, create pressure. So this is the answer, that gas molecules moving randomly changes the direction, cause a change in momentum, and due to change in momentum, exert force on a unit area that is responsible for creating a pressure. Question 5A. In this question, in an industrial process, a gas that is already at high pressure is trapped in a large cylinder by a piston. The graph shows the pressure of a trapped gas depend on its volume. So graph is given. First part, describe a relation between the graph, describe a relation shown by the graph between pressure and volume, and explain this relation in terms of molecule. So what is the relation? Increase in pressure, reduce the volume, means they are inversely proportional. Because the product is constant. And how in terms of molecule? So when we increase pressure or when we reduce volume, gas molecules collide more often with the wall, increase the pressure. This is what will happen when we increase the pressure, the volume decrease, or we can say the product is constant because they are inversely proportional according to the graph. And when we reduce the volume, it means the molecules are closer to each other. So they will collide more often with the wall and exert high pressure. Determine the volume occupied by the gas when it is released into atmosphere of 0.1 megapascal. So we know the pressure. So how we can use the data? We have the formula P1 V1 equal P2 V2. So I can take this as P2. V2 we are finding, that's unknown. But what about P1 and V1? So as we know, when two quantities are inversely proportional, so we can take any point. So pressure at any point, like example, if I took this as the point, so pressure at this point is P1 and the volume at this point is V1. So pressure P1 is equals to 10. 10 megapascal. V1, what is V1? When you check the scale, so there are 10 boxes, each box is about 0.01, so this will be 0.02. P2 we don't know. Sorry, P2 is 0.1. That's given in the question. V2 we don't know. We are finding V2. P2 is 0.1 megapascal. So 0.1 exponent 6 I can substitute. But because it is a ratio, so I don't have to convert the unit. So when I solve this, I'll get the final answer. Is it clear? Nine part 2. Question 9 part. As a balloon travel upward through the atmosphere, the volume of the helium increases. The temperature of remain constant. State the equation that relates the volume and the pressure. So pressure and volume, the PV is equals to constant. That's a equation. Or you can say P1 V1 equal P2 V2. Both are the same things. So use the figure, determine the pressure on the ground level. So when it is at the ground level, the height is 0. So at the ground level, the height is 0. So when the height is 0, what is the pressure? 100 kilopascal or 100,000 Pascal. Use a figure, determine the height at which the volume of the helium balloon is twice the volume on the ground level. So pressure and volume are inversely proportional, as we know. So if we want the volume to be double, then the pressure should be half. Because we have to determine the height at which the volume of the helium balloon or helium in the balloon is twice the volume at the ground. So if volume is double, the pressure should be half. So if original pressure was 100, half of the pressure will be 50. So at 50, we'll draw a line from 50 mark. This is not the volume, this is a height. Because at the ground level, when you release the balloon from the ground level. So when you release this balloon from a ground level, it was having some volume, but we don't know what is the volume. But we know the pressure at the ground level, the pressure on this balloon was 100 kilopascal. The question is, we have to find a height when this volume of the balloon is twice as compared to when it was released from the ground. Like it became double. It became 2V. So if volume become twice, the pressure should be half. So what will be the pressure? The pressure will be 50 kilopascal. When the volume is double, we don't know what was the starting volume and we don't know what will be the final volume. But because what happens if the volume is double, the pressure will be half. So if the pressure is half, so we'll draw a line from 50. So between 40 and 60, we have 50. And then we will find at what height. So between 40 and 60, we have 50, and then we will determine or mention the height. Is it clear? Discussion? Any other doubt from this exercise 2 of matter and gas laws? (19A). Okay, in this question, the molecules of a liquid are the molecules of most liquids are on average slightly further apart compared to that of solid. State one other difference between the molecular structure of a solid and a liquid. So what is the difference between molecular structure, like in terms of molecule, how a solid and a liquid are different? Basically, in a solid, the particles are tightly packed together. There is a regular arrangement or without any gap. The next part, the next part is now a glass tube which passed through a stopper into a glass flask, as you can see, shows that the flask is completely full of liquid, and there are some also liquid in the tube. That's called capillary action, like liquid rises in the tube. In the question, the flask is immersed in a large beaker of hot water. So we take a beaker, a container, and we immerse this in a hot water? At first, the level of the liquid in the tube fall, like say example, if I say this was at position A, first what we observe, it fall to position B, and after a short time it rises to another position C. Explain why at first the level of the liquid in the tube fall. What could be the reason? Look, first what happened, the heat is supplied to the flask because the flask is in contact with the hot water. So what, as the heat is supplied first or taken by the flask, so the flask will expand or the size of the flask will increase. At the beginning or start, the flask will absorb energy. So as the flask will absorb energy, it will expand. So as it expand, what it appear? It appear that because the volume of the flask increases, that's why the level of the liquid will come down. So flask absorb energy from hot water, expand, so its volume increase. That is why level of liquid will fall. Because in the large container, now comparatively container become large, so that's why the level of the liquid decreases. But why the level of the liquid rises in the tube? Why it stop falling and then start to rise? What is the reason for that? Now the energy is transferred from flask to the liquid. So when the energy transfer from flask to the liquid, now the liquid will expand. So as the liquid will expand, the level of the liquid will rise. So liquid absorb energy from the flask and liquid expand more than solid. Like otherwise, if they were having a same expansion, that we should not observe any change in the volume. But practically liquid expand more. So liquid absorb energy. And expansion of liquid is greater than solid. That's why it rises in the capillary. Is it clear? Discussion? Any other doubt from this exercise? Three A. The hot plate was switched on and the temperature of the water and in the pan start to increase. When the temperature of water is below 100, some of the water evaporate. At 100, the water start to boil and its temperature remain constant. Pan A is small area compared to pan B. State and explain which pan has the greatest rate of evaporation when both pans of water are at same temperature. So pan A is having a small area compared to pan B. So if we have two pans but different areas, the one which is having a large area will show a greater rate of evaporation. Because more molecules are exposed to surrounding, so number of the molecule which escape the liquid surface will be higher. So pan B will have a greater rate of evaporation compared to A because more molecules are exposed to the surrounding. For pan A, few molecules are exposed to the surrounding. Any other doubt? So we'll start our topic. Boiling is not affected by surface area. Basically, when outside pressure and inside pressures are same, we call that substance is boiling. So boiling depends on pressure, out atmospheric pressure, the boiling temperature, but does not it's not affected by the surface area. Like example, if you are boiling a water in a small container or you are boiling a water in large container, if you have equal amount of water, you need same amount of energy to boil both of them. So boiling is not affected by surface area.